Welcome, everyone, to the ISM Rochester Lunch and Learn webinar series. I am so happy to bring our guest for today's program, Stephen Nichols, who I've known for a few years now. He is the founder of Banyan Business Outcomes, and the topic for today's discussion is smart contracts and blockchain. So please be sure to ask your question using the chat or the Q&A, as we do enjoy making this an interactive session. If you would like to ask your question live, just raise your hand and we will give you the mic at that point. But at this time, I'd like to turn the program over to Stephen.
Yeah, thanks, Kathy. I really appreciate it. Thanks everyone for jumping in and joining us for this conversation about blockchain and smart contracts and supply chain and how all of this is going to revolutionize the industry and solve everyone's problems. But as Kathy mentioned, I do absolutely appreciate if you please interrupt with questions and break up the presentation. These Zoom presentations can feel a little isolating when you're just stuck in your office. So I really would love to have comments and questions in the middle of it to kind of break that up. So I'll share a presentation if that's okay. And Kathy, let me know if you have any trouble seeing that. This screen. But as Kathy mentioned, I'm the founder of Banyan Business Outcomes, which is it's a company I founded about a year ago. I'm focused on helping companies get better value out of their spend with technology vendors. And that includes everything from things like strategic sourcing initiatives, through building out vendor management offices and vendor value governance capabilities. So for me, for smart contracts and for blockchain, I think there's an opportunity for doing things like verifying third-party risk or cybersecurity certifications, or environmental stance and those kinds of things. So I'm kind of thinking about some business ideas relating to all of this. And that's why I've been researching the topic and trying to get a little more knowledgeable about how this all fits together. So with that, I'll kind of dive into some of the research and provide some context. I guess I should say too, I'm doing something a little different with this presentation. It can be quite dry, right, to talk about blockchain and technology. So my idea here is I'm going to talk about some metaphors, talk about some use cases for the technology, and then back up and say, this is what the technology is actually doing behind the scenes, and then move a little farther forward with some more use cases, and then back up a second time. And in that way, I think it could be a little more engaging than what it would be if I, just treated this like it was a lecture or something like that. So in any case, I'll dive into it. We're talking today about smart contracts, which of course is an improvement over paper contracts, or I guess in this case, clay tablet contracts. That's an example of one of the first contracts that we have that was written in cuneiform back in Sumeria 4,500 years ago. I think it was a marriage contract is what that was. And then there's a whaling contract underneath it that was just a few hundred years ago. But contracts are everywhere. Paper contracts or written contracts, of course, are a part of all of our daily lives, working in supply chain and procurement. But also there's verbal contracts that happen on a regular basis as well. And both paper contracts and verbal contracts are rife with certain kinds of problems that can arise pretty frequently. So I'll tell a quick story about a verbal contract that I had that goes back about 20 years. But the year was maybe 2000. I was, 19 or 20 years old, and I was in North England. No, I wasn't. I was in Redditch, which is kind of central England, I guess, in the rural part. So imagine like rolling green hills, that kind of thing. So I'm in a pub in this small town with a few hundred people on a college classroom trip kind of thing. And I was 19, 20 years old. So I was really thought it was kind of cool to be in a pub and ordering a beer in public, right? Because of course that's illegal in the States. And I ordered the beer and I put a 20-pound note or a 20-pound note on the table, and the bartender picks it up and then hands me back something like a 5-pound note back. And I said, well, how much was the beer? And he said, well, it was like 5 pounds. And I said, well, I gave you a 20. And he said, no, you didn't. You gave me a 10. And I said, oh, I think I gave you a 20. And he said, no, it was a 10. And he just turned his back on me and walked away. And I, of course, had no recourse, right? Because I'm in rural England. Just take the L. You're not going to get the money back. Yeah, when I would call a constable, have him count as change, that's not going to work. So that was an example of a verbal contract that either through human error, my error, his error, or perhaps even untrustworthiness, perhaps he was trying to have one over on the American, went wrong, right? Because the transaction didn't quite work right, because there was a human interface and potentially some deceit that happened too. So that was an example of a contract that didn't go so well, and something that could have been fixed with a smart contract like situation. And we'll get into that in a second. Another thing I put on this slide was multiple parties. And I think maybe this is a common experience for a lot of people, but I was also once, this is another beer story. I was in a bowling alley, and a group of us ordered a pitcher of beer to split, because I'm classy like that. And we got the pitcher of beer, and everyone pitched in for it. And then one of the guys didn't get any beer, even though he had paid into it, because just the pitcher ran out before he got to pour it. So contracts that involve multiple parties, verbal contracts or written or paper contracts that involve multiple parties, can often end up with, one person not getting what he needs out of the agreement, right? Having some kind of problem. So those are issues with verbal contracts and written contracts. Another source of problems with third parties. So banks and courts slow the process down. They add additional cost. In some cases, courts might not quite understand what's going on in the contract, and you might lose a case, or lose a ruling that you'd like to see go your direction, and that can create friction problems, and really limit what can happen with a smart or with a paper contract. Brokers as well. Brokers are awfully expensive. Anyone who's ever sold a house, and I'm friends with a lot of real estate agents, so they kind of know this too, but it's a big percentage, right, that you give up of the house. It's a lot of money that gets handed over to those real estate agents. So these third parties that sit between these middlemen between two parties that are trying to transact can be very expensive and very slow and cumbersome, and can create errors and issues and that kind of thing. Smart contracts are one way to eliminate some of that friction and some of those problems. Okay, so that's some context. We're going to get into what actually smart contracts look like. So there's a phrase that's commonly used in smart contracts, which is code is law, right? In the case of a smart contract, the code, what is written out, is the mechanism by which the transaction is processed. So it is, in a sense, a substitution for law. Right. Normally, when you have a contract, it's written out, these terms and conditions, who's paying who for what they're getting for their in exchange for that payment. All of that is built into the code, as opposed to being into a paper agreement. And that's the very top level, and something to try to keep in mind. The benefits of this is that they're deterministic. Deterministic smart contract means that you know what you're going to get when you do it. You can anticipate the outcome of this, and there aren't any surprises. It's immutable. So a smart contract is written on the blockchain, which means it's very, very difficult to change. It's impossible to change once it's been put in place. You can only amend it. It's distributed, which means that no one party owns the contract or the platform on which it is hosted. And it is transparent, meaning both parties can see the mechanisms behind it. So the common metaphor for explaining smart contracts is a vending machine. So when I walk up to a vending machine, I put in money, and that is, in a sense, instantiates the contract. And then I push the button on the vending machine that says what I want. In this case, draft bitter beer. I've never seen one of these before, but I think it's a great idea, and we should do it. So I can buy beer out of a vending machine, right? So I push my button, whatever I want, and then the product comes out of the bottom. So it's deterministic. I know exactly what the outcome is going to be when it comes out. And this works fairly well. So the three phases are, first of all, you fund the account, which is I put in my $5, and the vendor of the beer puts in the beer. I select the beer that I want, and the beer is dispensed. Three steps like that. So you could almost make a beer vending machine into code. And on the right there, that's an example of what the code would look like if you were to codify a vending machine, or codify a beer vending machine, right? And you can kind of look through that. And if you're familiar with code at all, then that might make sense to you. So there's a limitation to this metaphor, though, because with a vending machine, the vending machine is owned by the beer company, or whatever vending company is filling it up for me, right? It's typically I'm walking up to a vending machine that I've never seen before and buying the product, and it's owned by somebody else. It's owned by whoever puts the snacks into the system itself. I guess in theory, like I could, buy a vending machine and then have other people stock it for me and then pay it, and then I could own the machine, but that's just not the way that it works out. So the why that doesn't quite fit with smart contracts is that I, as a consumer of this, really have no opportunity to audit the mechanisms and the code behind the vending machine to see how this thing actually works, and to confirm that when I put my payment into it, I'm going to get the result that I expect. But with a smart contract, you do have visibility, just as you see on the right there. You have visibility into the code or the mechanism that shows how things are working. The other limitation is that the vending machine, as I said, is owned by the vending company. And in a smart contract, the vending machine or the smart contract, it lives on the blockchain, right, which is hosted independently of both of the two parties. So neither party really owns that agreement, and that creates some level of trust, because whereas a vending machine owner might, maliciously change the code so that they steal every once in a while and take a little money, and I have no way to anticipate that. If the code is available, if the mechanisms are available for audit beforehand, well, then I can check and make sure it's okay. And that's one of the advantages of the smart contract, is you get to see how the system works and that it's owned independently, right? Okay, so beer vending machines, great example, or great metaphor rather, for smart contracts, but not terribly practical. But I would like a beer vending machine if anyone is in the industry and can make that happen for me. Okay, so a better example, I guess, would be crop insurance for smallholding farms in Africa, which is kind of a remote example, but it goes something like this. So let's say you're a farmer. Farmer's business partner is the weather, and the weather is somewhat unpredictable, of course, and can at times cause real problems. I actually have a little bit of an agriculture background. I grew up in a rural area, and I have a friend of a friend who had his cornfield destroyed by hail 3 years in a row, which is just bad luck. Like that just randomly lightning struck or hail struck. It's like Zeus got mad at him and decided to whack him 3 times in a row. So he would have been wiped out had it not been for the insurance that he had in place. And the insurance works like this: if you have some kind of big weather event that destroys your crop, then you submit a claim and the insurance pays out the value of the crop or some percentage of the value of the crop, and that keeps you going for the next year. And it's really important, because if farmers were facing the risk of going out of business for one hailstorm, well, then they wouldn't be farmers anymore, because no one in their right mind would take on that risk. And we kind of need farmers, because all of us get hungry from time to time. So the issue in Africa is that about 80% of the food they produce in Africa is produced through smallholding farms, which are going to be an acre or two. They're typically subsistence farms that are done by hand, not with these big tractors by John Deere that are $1 million, are really expensive. So these individuals who are running these farms are still, though, susceptible to the same kind of weather events that could destroy their crop and therefore wipe them out for the year. Unfortunately, only 3% of these smallholding farmers in Africa actually have crop insurance. So the vast majority of people just kind of get wiped out if this ever happens to them, and that's a big problem for them. But the industry has been limited in offering these products for a few reasons. First of all, the policies would be very small, right? Because you're only covering a couple of acres, 2-3 acres, and the dollar value of the crop isn't that high. So any kind of transaction cost or administrative cost over the top of that would be overly burdensome for the value of the policy. A second problem is that governments in Africa tend to be less modern than the government we enjoy here in the US. So there can be issues with corruption, or simply the internal workings of the government haven't been built out yet, so things can be slow. And there's a distrust also with the government that many of these smallholding farmers might have. So those are issues too. And then there's just general distrust of these big insurance companies. So smart contracts are a great opportunity for smallholding crop insurance, because it's essentially setting up a vending machine for insurance, right? The farmer can go on with their mobile app and they understand how the system works, so they can fund the account. They can select the policy that they want, and then the system works. So the way it works in the back end is both sides fund the account. The farmer puts in $2,000, whatever the number is, and then the insurance company puts up the $100,000 policy, or whatever the number is, for the year. And those things are both submitted into accounts that sit on the blockchain. And then conditions, deterministic conditions are set up that determine whether or not the farmer is going to get a payout. So for example, if it's 95 degrees plus for 5 consecutive days, then the smart contract is automatically triggered, even without, in some cases, without the farmer making a claim against the policy, and the farmer automatically receives a payment of $100,000. So just like just like the vending machine, you're putting your money into the system, you're choosing, or just like the vending machine, you're funding the account. The condition or the selection is being chosen, the 95 degrees for 5 consecutive days, deterministic, that's exactly what's happening. And then the payment or the policy comes out of the bottom of it. So it works very much like a vending machine. And the effect of it is it pulls a whole bunch of administrative costs out of the system and is enabling a lot of these small holding farmers to have access to crop insurance that they never really had access to before, and hopefully making the food supply in Africa much more sustainable. Okay, so that's a lot to say. Let me back up one step into the technology though and talk about what blockchain actually is. So blockchain is probably best known for Bitcoin. Bitcoin is all over the news as the first cryptocurrency. The founders, of course, think it might replace the dollar eventually, but that seems to not have happened quite yet. Blockchain is the technology that underpins Bitcoin and Ethereum and all of the cryptocurrencies out there. And it's the technology that these smart contracts are going to rest on. Okay. So I'll start on the right-hand side. The first property of blockchain is that it's a distributed ledger, which means that there's many different copies of the ledger of the blockchain around the world in different servers. So if you have like a major currency like a Bitcoin, it's literally thousands of servers have a complete record of all of the entire blockchain and of this database that records who has what kind of information. Right. So it's distributed. No one party owns it. No one party can control it or can make arbitrary changes or can hold up your currency. And there are obviously some pretty big advantages to that, depending on what you're doing. So a blockchain is made up of a series of blocks, and those blocks each have 3 elements. So they have data, they have a hash, and they have the hash of the previous block. So I picture this as it's a database. So it's like a big Excel spreadsheet. The first column is the data, is the information you're storing. Second column is the hash, which is a representation of the data. And then the third column would be the example of the previous hash, which refers to the hash before it. So in this case, data for this blockchain might be Pete. The guy's name is Pete. Hash of that data, or the code that's semi-random that represents Pete, is D42. And then it refers to a previous hash of K16. And K16 is Samantha, and her hash is K16. The previous hash in that block is P12, which refers to Winona. And Winona's previous hash is G26, and it goes all the way back to the Genesis block at the very beginning of this. So, so what's really valuable about that is it's very, very difficult to change this. So let's say I have one of the copies of the blockchain on my servers back in my office or in my AWS account or whatever it is. And I say, well, I don't want the name to be Samantha. I want it to be Julie instead. Well, as soon as I change the name Julie, it changes the hash from K16 to H26 or some other number like that. And those are just random examples, but it changes the hash. So once I change the hash, though, Pete's block is really confused. It says K16, where's K16? K16 just disappeared. And the rest of the chain is looking at it and saying, H26, like I don't have H26 on my records anywhere. This block can't possibly exist. So it's going to reject that change as being inconsistent with the rest of the chain, and it prevents it from being edited. Now, in theory, you could go through and edit the entire chain and make it cohesive again by updating these previous hashes all the way through the chain. But that's the problem with it being distributed, because you would have to change it on 51% of the instances of this blockchain around the world, right? So I don't have to just change my own copy of the database. I have to change 1,000 others around the world, and that, of course, is extremely difficult or essentially impossible to do. So blockchain is an extremely secure technology where anything can be changed. It's immutable, and because of that, you can really trust it to keep a centralized record of whatever information this is. So whereas before, individual companies would have to have their own ERPs, their own individual systems that work with their own data that they trust because it's their data, it creates this opportunity for a shared database or a shared system that everyone has access to and everyone can trust as being accurate. So that's essentially what blockchain is, and there's a lot to talk about. I mean, blockchain could be or the technology itself could be, a graduate level class, which I think is what it actually is in some cases. But I wanted to just cover that and give some background. So when I go back to the previous slides and I talk about like a farmer's insurance policy being stored on blockchain, it means that this is the database technology that's managing that, and the insurance company doesn't have any opportunity to, edit it or create human error or some other kind of issue that might prevent a farmer from being paid out. It's immutable. It cannot be changed. And that means both parties are going to get what they're guaranteed. Okay, so another use case for blockchain, we'll go back into the actual use case or how it's actually impacting the world, is what's called decentralized finance, or which enables microfinance. And a good example of this is Uniswap, which is one of the leading blockchain DeFi providers. So let's say we go back to our farmers example. One of the issues with this, of course, is you have to find here this issue, this $100,000 that's going to be provided by the insurance company, right? You need to find a way to raise that capital to be able to offer the policy to the farmer. Well, let's say that, whatever it is, 15, 20 people or so who are on this call, all think this is a great insurance policy, and we all want to create this policy for this farmer. So we're all going to, just like we're buying a pitcher of beer, we're all going to invest $10,000, and that's going to fund the company for it. But the problem is all of us have to make that investment before the company's worth anything, right? If 10% of us make the investment or half of us make the investment, then there is no company. It doesn't work. So it works kind of like Kickstarter. What happens is you can create a smart contract that says this: everyone submits their currency, their coin, into this account, and it keeps track of who's made what kind of investment into it. And then the code says, once we have enough investment here, we shall make the policy available to the farmer. So it decentralized finance funds the insurance policy for the farmer. So this is why it's decentralized, because many people can do it, and because no one individual owns the technology or owns the platform on which it's working. So just like on Kickstarter, when you have 50, 100 people who all buy the $30 t-shirt to start the company, or whatever it is to get things going and get the initial financing for the business, you're able to do that, but do it in a codified way that isn't dependent upon some third-party broker like Kickstarter, and isn't dependent upon the honesty of the person you're working with, because you can understand the code before you've made the investment, and you're essentially setting up that vending machine kind of experience. And then, of course, at the end of it, investors earn a return, and the return can be automated as well on the back end. Now, DeFi and microfinance, there are companies that are doing this. It's on the edge. This is cutting edge kind of things. And that's actually true of all of these smart contracts technologies and all the blockchain technologies. This is all pretty new. So obviously do your research before you get too far into it. One step back into the technology here, I wanted to go through what a token was and what a fungible and non-fungible token was too, because this is pretty relevant to the conversation. So just like blockchain technology, or a token is essentially blockchain technology, right? So you have your data, which is Joe has 4 tokens and there's a hash and there's a previous hash, and Larry has 200 tokens and there's a hash and a previous hash, and Sylvia, et cetera, right? It lists out who has what kind of currency on a blockchain that would represent any kind of token. So Bitcoin, for example, is a token essentially, or a currency that's being passed from one person to another, but there are other versions of tokens too. So you have fungible tokens and non-fungible tokens. Fungible means that one is alike, one is exactly the same as another. If I take out a dollar bill from my wallet, it's exactly the same as a dollar bill in your wallet. There's no meaningful difference between the two. That means it's fungible. If it's non-fungible, then my dollar bill would represent a specific thing that was unique, that no one else had a copy of that. And that's where you end up with things like NFTs, where you have an NFT that represents things like a house, right? There's only one house at 4558 Mead Street, And that's the one that's represented by this non-fungible token. So a fungible token is one that's exchangeable, they're all alike. A non-fungible token is one that's unique. So fungible tokens are being used in carbon exchanges around the world. This is a big issue for people in Europe because of some legislation. I have four of the leading carbon exchanges listed there on the side. But what it basically allows you to do is, as a company that wants to offset the carbon that's produced in operations, what I'm able to do is to go out and buy tokens, buy these fungible tokens from other businesses or other organizations that are doing green projects that are, reducing the amount of carbon footprint or pulling carbon out of the atmosphere or those kinds of things. And essentially what I'm able to do is kind of fund these projects by buying the tokens that are issued as they do it. So if there's a wind farm somewhere and we decide that the wind farm is removing, 5,000 metric tons of carbon every year from the atmosphere, well, that's great. And as a business, and I'm over here with my plumbing company or whatever it might be, I want to support this wind farm. What I can do is I can buy a token that on one of these exchanges that represents the carbon being pulled out of the atmosphere by the wind farm, right? So this is something that's actually, out. You can go on any of these exchanges tomorrow. You can buy carbon offsets, and that's an example of a smart contract on blockchain. Now, blockchain fits elsewhere too, and I thought I'd go through a couple of the use cases. I want to talk about healthcare and talk about supply chain, which is probably the most apropos thing for the group here today. Healthcare is interesting because, because of this. When you look at healthcare, there are a lot of examples of records that need to be kept independently of any one healthcare provider or insurance company. And that's one of the things that Patientory does. So Patientory is a company that allows you to store all of your healthcare records on a blockchain, and it's kept independently from your doctor's office or your podiatrist, your surgeon, whoever else you're working with. It's kept independently, and it stays with you as opposed to with those individual doctors. So everyone is able to trust that the records have not been edited or there's no error going into it because it's mutable. And it's independent from any one doctor's office. So you're not dependent on this, your primary care physician sending records around. Another example of this is what the Institutes for Risk Stream Collaborative has done. This is an organization of insurance companies. So health insurance companies have this challenge. Every 90 days, they have to call all of the providers that work with that insurance company and confirm basic information like names of the doctors, the address, the phone number, fax machine, that kind of stuff, just to keep their records up to date. So imagine, if you will, like a big insurance company probably has 100,000 providers that they're working with, and then there are 500, 1,000 insurance companies around the country that are all working with 100,000 providers. So the number of calls that have to be made to confirm all those basic details is pretty staggering. And there's a whole bunch of redundant work because every insurance company has to do exactly the same thing to make that happen. So this is a great example of where we can create a database that's independent of any of the insurance companies, and then have everyone work on that database in community, right? So we're all sharing that data and not having to duplicate the effort to generate separate databases that aren't meaningfully different. So I talked to the organization that actually developed this for the Risk Team Collaborative, and it was an interesting project. What they've done is they've set up a system where essentially people can be rewarded for doing the research, for confirming the details of the doctor's offices, meaning they're compensated in one way for updating the database on a regular basis. And that can be done by anyone in the collaborative, any of the insurance companies that are participating in the product. You can also be rewarding for correcting an error. If someone makes a mistake, there's a process for challenging some data that's been submitted to the system, and then you can end up being rewarded if it turns out to be correct, that the doctor's office has changed their phone number or whatever it might be. So that's a great example of where semi-competitors can work together to lower everyone's cost and to hopefully impact healthcare costs for us as individuals. And then the final example is Many Ledger, which I think is a really interesting company. One of the issues with things like pharmaceuticals is you have to be able to trace the whole supply chain cycle, right? To get that pharmaceutical, that product into the hand of the consumer. So you really need to know who produced it. You need to know, who shipped it from here to there, who the wholesaler was. Like the entire chain needs to be documented. And that's what MetaLedger is able to do, is it creates a record on the blockchain that follows that product as it passes through all those individual and separate and discrete suppliers until it gets to the end consumer. And then what's interesting is if the product gets returned, right? So if the pharmacy doesn't use the product and returns it to the wholesaler, but the product is still usable for some reason, then the wholesaler is able to still instantaneously grab the record that traces that product's life cycle and can verify that it is what the pharmacy says that it is, and meet certain regulatory standards, so that they can resell the medication as opposed to simply throwing it out. So awfully useful, and that exact use case is also used in food production too, and we'll get into that in a second. So 3 interesting cases in healthcare that I think are going to hopefully help all of our lives get a little better. So I wanted to get into supply chain, and I have 4 or 5 more slides to talk about this. Of course, I'll pause for questions and let me know if anything comes up here too. I'm happy to have a conversation about this. I think everyone on the call is aware of how complex supply chains are. I read an HBR article, and maybe it was 2 issues ago, where some professors did some research into supply chains. What they found was that any one product that you might buy has 14 individual suppliers behind that. And then those 14 suppliers all have 14 suppliers, and those 14 suppliers have 14 suppliers. So you very quickly, when you look at 2nd tier and 3rd tier suppliers, can end up with thousands of companies that all come together that produce any one pen or any one product that you might buy. So they're extremely complex. And the HBR article found that one of the problems was that some of these suppliers were represented multiple times in the same supply chain. So I'm thinking primarily of like shipping companies. Like if you're having DHL that moves things, from 4th tier to 3rd tier, and then 2nd tier to 1st tier, if there's a disruption from one of the shipping companies, well, that can affect multiple phases of the supply chain, and those effects can ripple down throughout the organization and create some kind of issue. And honestly, I'm sure that everyone has dealt with that over the past few months with all the supply chain trouble we've been having. So creating visibility into the supply chain and being able to verify where products are in the supply chain and understand it is of critical importance. And smart contracts and blockchain are going to have a big impact on how that is done. So there's really 4 different areas I wanted to go through with supply chain contracts. There's authentication, alerting, visibility, and payments. And we're going to look at some companies that have solved problems in each of these 4 different areas for smart contracts. So the first one is authentication. So authentication, there's an interesting company called OpenPort that has built out a platform that sits independently, right? It sits on the blockchain. And meets that description of being like a vending machine kind of experience. So what it does is it creates a record that simplifies all that shipping and transporting that happens with any one product or any one raw material moving throughout the supply chain. It creates a proof of delivery solution. So I'm using things like Internet of Things devices that monitor when a product has been delivered to a specific location. And then it demonstrates that as proof of delivery and can automatically trigger the smart contract to send payment or at least update the system so that I can track where things are in the supply chain. It can tie payment to the flow of those goods. So for example, if normally when you have a product arriving from one warehouse to another, payment gets delayed 30 days or whatever it takes for the paperwork to get cleared. Well, if there is no paperwork and it's all based on this smart contract technology, that payment can be almost immediate, right? Essentially immediate, and it can be fully automated so that no human individual has to actually verify that the transaction went through, because they're able to see that the contract automatically triggers and codifies the payment. And then it creates improved visibility, right? You're able to see exactly where the product is in the entire chain. So OpenPort is an awfully interesting system, and there are a couple of competitors to it, but honestly, all of this stuff is pretty new and pretty pretty cutting edge. Payments is the next section. SKU Chain is a really interesting company that has quite a number of solutions, including some of the things I just mentioned in the previous slide around authentication. But payment essentially is allowing for currency, especially in currency for trade, to be handled through blockchain. And that reduces quite a bit of work around things like letters of credit and bill of lading. So SKU Chain has developed essentially an alternative to that letter of credit or bill of lading system that cuts out a lot of that bank interference and speeds up the transaction, but does so in a verifiable way where you can trust the system will work even if you don't trust the international supplier that you're working with. There's also a system built out, which is collaborative resource planning, that is awfully interesting. You've seen enterprise resourcing planning. Everyone has an ERP system. Most people don't like their ERP system, but everyone has one, and that tracks how things are moving through the system and getting manufactured. Well, collaborative resource planning system is very similar to that, only it's talking about the whole extended enterprise, meaning all of your suppliers are participating in the same centralized CRP, collaborative resource planning system, and you're able to track things the entire way through. And then there's proof of provenance, which shows the provenance or where how products were produced and how things have moved through the system. So SKU Chain, and there's quite a bit of technology that they've developed there, and it's an awfully interesting company and maybe worth looking into. Walton Chain and LinkLogis are also fairly interesting. These are Chinese companies, so there's a little bit of a language barrier when you look into this, but Walton Chain allows for that payment for international trade and eliminating that letter of credit bill of lading side. And then LinkLogis, LinkLogis does something fairly different from all of that. Actually, I want to get into that. So LinkLogis does this essentially. As I understand it, one of the common practices when you're working with a supplier, especially an international supplier, is that funding can flow down through the supply chain. So there's an end user company that's ordering a certain product, and because they're ordering the product, the supplier has to produce the product before they actually get paid for it. So you end up with a cash flow issue. So there's a separate financing arm that's going to finance a production of that product that the end user is going to use. And that's maybe worth 80 or 90% of the value of the product being produced. And then that supplier has other suppliers, so the second tier supplier too. And the second tier supplier has the exact same problem. They have to manufacture the thing and knowing that they're only going to get paid 30, 60 days after it ships. So a portion of the funding that happens from that financing company needs to pass through to the second tier supplier and to the third tier supplier and the fourth tier and fifth tier and so on until you get down to the raw materials coming out of the ground. So instead of using a separate financing company, that has paper-based contracts that can be, have too much administrative overhead and that kind of thing, LinkLogis allows us to use blockchain technology to be able to pass payment all the way down through all those layers, and then pass information showing demonstrating the delivery of each of those composite agreements all the way back up through the chain to the end layer. So a really interesting technology and something that probably is pretty immature, but probably still getting developed here. So that's payment technology, and that's DeFi, and that gets really complex. So hopefully that was pretty helpful, but we'll see. The next area is alerting. So I've worked with Pixelplex a little bit, or I have a little bit of experience talking to them about some of the things they've developed around alerting around specific technology. So they worked with a large computer manufacturer that everyone knows on this call. Everyone's worked with them in the past. That manufacturer had a problem where they were shipping around million-dollar servers around the country. And if the truck that was delivering that server went over a set of railroad tracks at 50 miles an hour or something like that, and there was some kind of jar that happened, it could damage the server before it comes out. So they developed the technology using Internet of Things or sensors and monitors to sit in the packaging and monitor whether or not there was some kind of jarring motion that happened in the package. And then using blockchain, it gets reported back up to the person who's receiving the goods. And it might say, yeah, you need to look really thoroughly at the server because there could be a damage. There could be some kind of damage to the equipment because of the way that it was transported from here to there. Tive is also is one of the companies that's developing the sensors or the Internet of Things sensors that actually monitor things like the jarring or the disruption that happens to the package. It also does like temperature sensing as well, which is highly useful if you're shipping food from here to there and you want to make sure the ice cream didn't melt or the beer didn't sour. So Tive is one of the IoT companies that feeds into all of this. And then Tenderly is a company that's developed alerting technology for every phase of the blockchain. So as you see products passing through that whole supply chain cycle, Tenderly can report back to you as the product is approved or as a product passes through the cycle, and you can understand where your product you're going to get in a year from now is actually in the cycle. And the third area is visibility, and I have a few different companies here listed. Each of these work in different industries, really. SyncFab at the top, I guess, has some experience around medical and aerospace, that area. Everledger is a company that also works in the area. TE Food is working with food industry, tracking that whole supply chain. And then ManyLedger I mentioned before, but they're tracking pharmaceuticals. What visibility means is you need to understand the origin of the product, where it was produced. You need to be able to guarantee that the product hasn't been counterfeited at some point. You need to, in the case of food, you need to understand, which farm it came from and which supplier put it here in case of some kind of outbreak or some kind of issue that needs to be addressed. So blockchain as this centralized repository for information across all the different suppliers and smart contracts as well, of course, creates an opportunity for us to have visibility all throughout the supply chain. And that's something that's, a current use case. These are all companies that are actually working and, you can do business with tomorrow. So in terms of supply chain, just to review, we have authentication, alerting, visibility, and payments. And those are ways that we should expect smart contracts to impact probably everyone on the call over the next 10 years or so, 5-10 years, as the technology really starts to ramp up and get pretty warm and pretty exciting. And that's, I guess, what we're all looking forward to. So those are the slides that I had, and I would love to open this up to questions, and hopefully I can answer a few.
Okay, I don't see any questions in the chat so far. If anybody has a question for Stephen, this would be a great time since he's here live with us right now and he can answer any of your questions. Stephen, any challenges that you've seen that companies have had?
Yeah, and so it's all new technology. This is not well established. This is not, this is pretty cutting edge. So you really need to, look at the company that you're working with and make sure that you can validate what it is. You also have to be willing to kind of go the extra mile to, help the company, help the vendor you're working with develop the product. Mitsubishi just announced they did a large transaction for some of their raw materials. It was their, I think it was metal. They bought some kind of metal using smart contracts and using one of these technologies. And that's, it's a forward-thinking kind of thing to do, but it's not yet commonplace and not yet quite as easy as it could be.
Okay. Any closing remarks you'd like to make to the audience? Oh, wait a minute. We do have a question just came in. What are measures of the amount of degree of adoption of these blockchains?
I've seen a few things. I've seen a few examples of this. Let me grab this. There was a company I mentioned before. Uniswap was the company that did the microfinance, and they've pushed something like over $1 trillion worth of business through their platform. Now it's a pretty mature blockchain company, so I would say that's a pretty good measure of adoption, and that's pretty well adopted. You can also look at the valuation of things like Bitcoin and Ethereum, which is Ethereum is the version of blockchain that supports all these smart contracts. or most of the smart contracts. So the value, the market cap or the value of all of the Bitcoin, I think, is also an example of how much people have adopted the technology. Yeah, and then you'll see other sites that talk about the number of transactions, or they'll have the big logos, you know, they get listed there too. So that's all probably a relevant way to look at this kind of stuff.
Thank you very much. If anybody else has a question, please make sure you put it into the chat. At this point, though, I would like to ask you if you have any closing remarks, suggestions, if, for anybody on the call, if they want to start something like this or work on it.
Yeah, you bet. I mean, I think with all technology adoption, you focus on the problem that you're trying to solve, not the solution that you might buy. So, what that looks like is, I need better visibility into my supply chain, or I need to offset my carbon footprint, or whatever the problem is you're looking for. Start there and then work your way down into the technologies that can meet that requirement. And then finally choose the need that you have. So blockchain is likely what you'll see at the end of that process of understanding your requirements. But you wouldn't want to start with blockchain and then work your way back up, unless you're really interested in blockchain, which you could be.
Okay, I see another question. What happens if a server that has the chain crashes, break the chain?
Yeah, so it's a copy of the blockchain is stored on all of the servers. So if you have 1,000 servers and one of them goes down, then the system doesn't really notice that happened. And that's one of the advantages of being decentralized, right? Any one interruption for one server doesn't take down the entire network.
Yeah, and I would think the most important thing is the visibility.
Yeah, right. It's decentralized. Everyone has access to kind of see what it looks like, and it's not like, well, if you have centralized finance, for example, I mean, the Federal Reserve, keeps track in one giant database of how much money everybody has, and it's totally centralized. And the Federal Reserve, if they ever go down, heaven forbid, then it creates a massive problem for everyone on the planet, because it's totally centralized. And if the Federal Reserve creates some kind of rule, or let's say they don't like what you're doing internationally, you're a Russian oligarch or something like that, they can use that in the SWIFT system to lock down your funds and prevent you from using that. But when it's decentralized, and when there is no governing authority over the top of it, then that system works independently, and there's no opportunity for one server to go down, or for one third party to make an arbitrary ruling, or any kind of interference. Like the system all works. It's really immutable. It's really impossible to change that.
Thank you so much.
Which is sorry, it's good and bad, right? There's a reason that all of the ransomware out there is asking for Bitcoin or some kind of cryptocurrency, because if they ask for money, they ask for dollars. Well, the Federal Reserve knows who they are, or knows which account it goes to at least. But if they ask for cryptocurrency, it's untraceable. It's just an account number, and no one knows who owns that account number.
Okay, another question came in. How do we account for volatility and the value of tokens in public blockchains, especially regarding blockchains that serve a purpose like VeChain or Uniswap?
Yeah, so like this is stable currency is the technical answer to that. So stable currency are cryptocurrencies that are anchored to something that's much more stable, like the value of the dollar, for example. You might have it instead of floating freely like Bitcoin does, it might always represent $1 or some kind of source of stability. And I think that's not how Ethereum works, but there are stable coins that are out there. Cargo coin, I think that's one of them, but I'm not really deep in that area.
Thank you very much. Okay, well, this has actually been a very interesting topic, and new topic for me, definitely, with a lot of the programs we've been doing over the last few years. But thanks so much. If anybody wants to get in touch with you, what's the best way?
Yeah, you bet. My email address is Steve or Steven.Nichols, Steven@BanyanOutcomes.com, or Steven.Nichols@BanyanOutcomes.com. Either one works. My phone number is on that slide. That's kind of hard to see, though. I should probably fix that. But yeah, please reach out if you have any questions about this. For my own purposes, I might mention that briefly. I'm thinking about using smart contracts and blockchain technology around third-party verification, right? So right now, there's this process everyone goes through to ensure that their vendors have the financial stability that they need to be able to do business with, or have the cybersecurity stance they need to do business with, or it might have things like environmental impact programs in place or that kind of stuff. And I think that's a great opportunity for using blockchain to verify the the business practices of first-tier suppliers as well as second-tier and third-tier suppliers. And that's a technology I don't think exists quite yet, or isn't being done quite this way. And that's what I'm noodling on after hours once the wife and kid have gone to bed.
Well, thank you very much. This has actually been a very, very enjoyable topic today, definitely. And at this point, I'm going to close out the show. I'm going to say thank you for joining us. Thanks for all our attendees. Thanks for your questions as well. We definitely love the questions because it really makes the program very interactive. And but thank you for all joining us. I will be sending out the recording a little later today with your continuing educational credit for joining us, of course. We hope that you will share it. Steve, if they would like to get a copy of the slides, is that possible?
Yeah, you bet. I'll make them available to you and you can forward them around if you want. Or,
Okay,
or send me an email, and that's fine too. So.
Okay, thank you so much. We'll do. Well, again, we're going to close out the recording at this point. Let me see. Thank you, Mark. Said thank you for the presentation. So at this point, we're going to be stopping the recording.